Okay, I'm going to talk to you about the atom and try and get you to be able to draw one. And then on the next YouTube, I suggest you go straight to the iron and how you draw an iron and what the difference is. So first off, we've got the atom. Now, I've got a code up here. I've got some protons here, which I've done red. Electrons here, I've got a little negative charge, and neutrons here are green. This is just a symbol of the periodic table. It's lithium. I've just picked one. You'll get a periodic table, remember, and it'll have the numbers, and it's got a little key on it on the periodic table. It says this one is the atomic mass, the relative atomic mass, and this one is the atomic number. And let's use them to draw an atom. Yes, let's. Right, okay. Now this is the mass. Now all the mass of the atom is in the middle, in the nucleus. And the subatomic particles that you find in the nucleus are the protons and the neutrons, and this tells you that altogether there are 7 of them. So we start by drawing 7 balls in the middle of our nucleus. Come on, upper. 1, 2, 3, 4, 5, 6, and 7. So there are 7 balls in the middle there. Let's turn that off. Right, there are 7 balls. So 7 subatomic particles. Okay, what are they then? 3 of them are protons. That's what this bottom number here means. 3 are protons. Let me write that down for you. Let's see if my pen will work. It would be good. So 3 are protons. Okay, 7 is protons and neutrons. Together then, the protons and neutrons have a mass of 7. That's because they each have a mass of 1 each. Okay, so the total lithium mass is 7. Electrons really don't have much mass at all, so that's why they don't come into this really. Let's move them over here. Oh, come on. Now, with these then, we know that 3 of them are protons, so we're going to colour 3 of these in red. Okay, we're going to colour them in red to match our key. So red, 1, 2, 3, leaving 4 neutrons behind. So 7 take away 3 is 4. 7 altogether, 3 are protons, leaving these 4 we've got to colour in green, which are our neutrons. So we can say that lithium has 3 protons and 4 neutrons by using just these numbers here. We need to put the electrons on. Now the electrons are important because this atom has no charge at all. At the moment this nucleus got a charge of +3 because protons have a charge of +1. Neutrons have a charge of nothing at all. Electrons have a charge of -1. So we need to balance these 3 pluses out, these 3 protons, by adding 3 electrons, and then it has no charge at all. So if I put them on, this would be a bit wobbly. Right, here we go. There's a shell. Now this it doesn't really exist. I mean, it's an orbit. It's a path by which electrons go whizzing around the nucleus. So we'll put 2 on there. We can only have 2 close up on that first shell. On all the other shells, we can have up to 8. Okay, so I put on 2. I need another one, don't I? There they are there. I could have used these things here, but I've put crosses. So I've got 3 electrons, 3 protons, so 3 pluses, 3 negatives. It's all balanced and lovely. That is lithium. Great. So if we drew it out, we'd have 3 electrons, 1, 2, 3, and I could just write here the neutrons was 4 and the protons were 3. It's always, that bottom number is always the number of protons and is also the number of electrons. The electron configuration of this then is 2, because there's 2 here, 0.1, because there's 1 here. Now if I was doing a larger one, it could be 2, 7, or 2, then 8 on this one, 1 on the other side, 2, 8, 1. Important bit about electron configuration, so really simple, you just say 2 and then 1. That number there, this last one, this one, that tells you what group it's in. Okay, so if it was 2 and then 2, it would be in group 2. That's it, that's the atom.